Thank you very much. I would like to say hi in front of the NIT Institute and the part of the NIT Institute that we call NIT Academy. And today I'm going to share our story by trying to contrast the three things. This is software, automotive engineering, automotive industry, and safety. First, we have electronic vehicles and ever-growing autonomy in vehicles, autonomous mobility, and this all comes down to the need for centralized computing. Centralized computing means that from a myriad of ECUs that we had in the car, now we have, let's say, 2 domain controllers, 3 domain controllers, and even converging towards a single computer for the car. This situation, of course, brings about the software people on board. So software and electronics, of course, so hardware and software. Hardware as in computers, like computer hardware and this kind of things. And software and software people, very, very complex software stacks with millions of lines of code, starts to engulf basically everything. And this is the situation that we maybe didn't talk this much at this conference, but when we look worldwide at what's happening in autonomous mobility, the keyword is software, definitely, and all the algorithms that need to process all the signals from all the sensors. Software companies are actually new tier 2s, and we also have new tier 2s in terms of these additional controllers that are being developed. And the existing tier 1 companies open up new departments dealing only with software and electronics and bring in many people from previously consumer and software industries that have not had any previous experience in automotive developments. One interesting insight that currently there are 250,000 new automotive software job ads in USA alone. And these are the ads that are being answered to all software people. So not only those that have experience in automotive, so they mostly do not have experience in automotive. And most of these people come out from universities that are not taught anything about automotive. These are like general software, computer science things where the V model is only, let's say, mentioned once or twice in one or half of the course. But vehicles are still vehicles. We still have all the safety and all the security requirements. We have all the processes we need to respect, and we need to make sure we are compliant, and this is why the legislators, of course, are the last ones to be asked. As I said, most of the electrical engineering, software engineering schools do not have safety-related subjects on the curriculum, and this is a big problem. Because if we want to do learning by doing, basically once you have a software guy or a hardware guy inside a company and then you want to make this person understand safety like immediately or through listening to YouTube videos or send him to a workshop of 3 days or something like this, you will get a person that is even more confused as opposed to being able to really embark to doing something useful. Yeah, there are different solutions. We can use different fast courses, online materials. Some companies resort to hiring safety managers, like, yeah, I should work more on safety. This probably means I need 1 or 2 safety people that comes on board. But the question is, what about the safety culture? And one of the most important things in safety is, in fact, the safety culture, the understanding of the safety process from the beginning until the end in all its phases. What are the inputs, what are the outputs, and then each of the phase in the V model, if we are talking about design, if we are talking about hardware or software or verification, has its specific methodologies that needs to be respected regardless the disruptive culture of the Silicon Valley or whatnot. And this is one of the answers that we crafted last year as NIT Academy together with University of California, San Diego, at their Department for Extended Studies. So this is a continuous education program in what is titled here Functional Safety Fundamentals for Automotive. And I'm very proud that my team and myself managed to craft this, and this is among the first really complete functional safety education programs there are on the market. We are not talking about, let's say, quick programs that you can get, let's say, this or that certification with the SGS or the quality people or whatever from that angle. But the programs which really mimic real experience, have hands-on exercises inside those programs, and allow you really to practice a field before you deeply dive inside some projects. And I will just show you in a bit how it works. So functional safety fundamentals for automotive as a program, it starts with a course on systems, functions, and safety. All the courses are designed in an intensive mode. This one starts on September the 1st this year, so the enrollments are currently open. This course is all about the big picture that is really essential for safety. So usually software people and hardware people think inside out instead of thinking from the big picture. So we here start from the system engineering, of course, as a general field, then dive into the requirements engineering, and one of the most common pitfalls currently in the designs, because of the bad or non-existent requirements, we have all the problems there are, because people don't know who to ask about the requirements, and the requirements are not given, they are elicited, etc., etc. So understanding all the key stakeholders, and then starting to understand how all this impacts safety, what are all the terminology in safety, hazards, risk, incidents, accidents, then the functional safety, and all the functional safety standards terms like the safety-related system, etc., and then diving into dissection of how the functional safety is designed, what are the safety functions, how those are evaluated against the safety standards, what are safety integrity levels, how those are calculated, and even we open up the field of reliability and how you actually meet those ASIL marks. So ASIL marks are not something on paper, some labels. These can be actually calculated. Those stem from hazard assessment, etc., etc. So these are like general precursors of safety that are really applicable both in automotive and in industrial and any other safety critical industry. Then we dive deeply in how we analyze safety, what are the methods there, like FMEAs, FMEDAs, FMECAs, EDAs, and everything else. This course, Safety Analysis Techniques, really gives you hands-on experience on how can you analyze safety of a system, and how you can figure out actually, do you have a problem or not regarding some compliance, regarding some figures that you need to meet. Then for specific system design field, we have the course on fault-tolerant systems. This means teaching people how to design systems that will be safer and that might meet the mark, what is the redundancy, what is diversity, and not only in general terms, but exactly how this is mathematically calculated and how we prove that the systems, how we can bring up the dependability of systems and the safety of systems as such. So this is really, really important course, and people are really, let's say, thrilled by having the chance to design different fault-tolerant structures and to design systems that have this fault tolerance built in. Then, of course, apart from all the design and, let's say, safety precursors, we have the processes and quality involved. You probably heard about ASPICE. This is, of course, something that is deeply analyzed in this course, Automotive Quality and Project Management. Students are actually practicing ASPICE through some project examples and learning what are the inputs and outputs of all the phases, what is the purpose of that, and how the process affects the safety integrity of systems, and that it is equally important as the design itself, and that actually if you didn't follow the process, you cannot go back, so you cannot rewind in time, so you need to respect the process from day zero, and this is exactly where they can pick up on this topic. And finally, once you have all this foundation set up, we are speaking in depth about automotive functional safety standards, and we believe that only at this point it is actually possible to dissect ISO 26262 and to understand really what it's all about when you know everything before it. And not only this standard, we are tackling SOTIF, we are also tackling some other functional safety standards if we have different industries involved. Here in this conference, we are dealing about automotive. We also have some electives, like functional safety software, how you actually make redundant structures in software, what is MISRA, how it's being checked, what you need to do in software specifically when it comes to functional safety, and the software chapter of ISO 26262, but not only listing it on paper, but actually practicing all these methods by coding small examples of that. Safety verification and validation, how you design correctly the testing processes, the verification processes, unit tests with appropriate coverage, etc. All these coverage matrix and everything else that is required to really make your safety case in the end. And we are currently crafting a specific flavor of cybersecurity course that we call Automotive Cybersecurity, that shall also bring up the knowledge in this field and also relate it to safety and seeing that it's actually catering to the very similar thing in the end of the day. So this being said, anyone enrolling on the September the 1st can go through the complete program, can go through all 5 of these courses and finish somewhere in February. The courses are designed so that you can work and learn. So it's mostly in the afternoon. You have some asynchronous parts that you do at home or with your groups with the help of let's say, our instructors that are online. Actually, this is one way, and this is, let's say, a preferred way. You can also handpick some of the courses, like starting from the first one, let's say take 1, 2, and 5. This is also possible, or 1, 2, 4, 5, or something like this. Different combinations are possible. UCSD gives the certificate, Functional Safety Fundamentals for Automotive. In case these 5 are completed, you don't need to complete everything in the first year. You can complete it some in the first year, some in the second year, etc. But it is very good that you can also select the courses and based on what you believe your knowledge currently is. And having said that, NIT Academy is also open to crafting different courses and curricula in B2B manner. There are, of course, many more courses in NIT Academy that are related to automotive. You can see just some of them here. It is mostly related to, let's say, automotive developments and verification. Let's say if you want to learn all about AutoSAR, there's a course for that. If you want to learn how deep learning is handled for the AVs, digital signal processing and complex hardwares for AVs, vehicle networks, protocols, infrastructure, how these ECUs are being tested using vector equipment and tools, and of course some required programming courses for the automotive. So all this is available, and you can also look it up at the website or get more info from our booth. And what I would like to say as a conclusion is that basically what we believe is the key to really handling this automotive stuff right is not the lack of research, is not the lack of algorithms, is not even the lack of processes and procedures. We have everything in place. It should click, but we believe that it is actually the lack of evangelized, so to say, knowledge among people, among engineers, among audiences, so that we are all on the same page, basically, and to understand realistically what can be done and what should be done about safety, and not resorting to some claims that might endanger the world, I would say. Because now, if you look at the US, we have a few incidents here and there with AVs, but we have just a couple of hundred, maybe at this point, maybe near to 1,000 EVs on the road. Just imagine if we crank up these numbers to tens or hundreds of thousands of those vehicles at level 4, for example, of autonomous driving. Without handling this right, it wouldn't be okay, definitely. And we all want this autonomous mobility to become a reality. So, for all additional information, we are at your disposal. And yeah, let's make this world an autonomous mobile place. Thank you very much.